But for this, I'd like to introduce Saju Salahudeen, who will be presenting Google GNOI operations demonstration. And just for those in the room, using GNOI capabilities is a way to simplify software upgrade use cases. Saju is a principal consulting engineer at Nokia and a member of the NANOG Education Committee. He's coming to us today from Toronto, Canada. This is Saju's first time, actually it's not your first time presenting. You've been here 3 or 4 times because I've seen you before. So sorry about that, and it's a pleasure to have you back again. So thank you so much, Saju.
Thank you, Steve. Good afternoon, everyone. Hope everyone is enjoying the conference. Before we get started, if I may ask for a quick show of hands, who has done a software upgrade in a production environment? Great. You are at the right place. Yes. Production environment is completely different from doing a software upgrade in a lab, right? Okay. So in this session, we are going to talk about the software upgrade process, look at some of the challenges that are there in that process, and then discuss a solution for those challenges. And then at the end, we will have a recorded demo. Unfortunately, NANOG will not allow me to do a live demo. So we'll have a recorded demo of using GNOI to do a software upgrade. So why do we need a software upgrade, right? Somebody can ask. I mean, my network has been running without any issues for the last 5 years. Why upgrade now? Right? There could be many factors. Okay. It could be triggered by market conditions. There could be a new fancy SRv6 service in the market that customers are choosing, customers are willing to pay a lot of money, and we need to have SRv6 on our routers. Right? Unfortunately, the current release doesn't support SRv6, so we need to do a software upgrade. Right? So that's driven by end users. Or within the organization, the management and the architecture team can decide, okay, now we need to upgrade our backbone to 800 gig links. So we need to have 800 gig line cards on our core routers, but unfortunately, the current software doesn't support those 800 gig line cards, so we need to do an upgrade. Okay. And then the network operations team, which is my favorite team in an organization, they run the real network. Anybody from operations here? Great. Okay. The network operations team might need an upgrade, most likely due to the current release going end of life, end of support, so they need to do an upgrade. But in addition to deciding for an upgrade, the network operations team is the team that's executing the upgrade. Okay, so they are responsible for the end-to-end process, starting from the planning stage all the way to executing the upgrade. Okay. So let's look at some of the items that the operations team will need to consider, during the planning stage and while doing the upgrade. Okay. So for sure, you're going from your existing release to a new release. So there is an unknown here, which is the new software release. So we need to test the new software release, make sure all the protocols and everything is working as expected, as it is today. So no differences there. And that includes testing the external interfaces, right, which is like TACACS or syslog interfaces, making sure the behavior is the same. And also testing your automation scripts, right? So your automation scripts might be written for a certain release, expecting a certain response for the API calls. We need to make sure that the new release, in the new software release, the API calls are returning the same response. There's no changes in those responses. Another key item that is overlooked many times during the initial stages is checking the compatibility with your management system, right? It could be a classic vendor EMS system or an open source application, or it could be a napalm driver, right, which is managing your router. Now those applications or drivers are written for a specific release. Now you are doing an upgrade to a new release. We need to check the compatibility with those drivers and the new release. And in some cases, you will have to update those drivers or even upgrade your EMS systems before you upgrade the routers, right? And that's often realized in the later stages of the planning for the software upgrade. Then the operations team also has to prepare a MOP, the method of procedure, how to do the actual upgrade. Okay. If there is an existing MOP, they might have to retest that MOP or make modifications to that existing MOP. They also have to take care of the sparing. So on the night of the upgrade, if something goes wrong, they have to make sure that they have enough spares to cover, to replace the cards or replace the boxes. They also have to plan the maintenance windows and inform end users. So in case there's an outage, the end users have to be informed that your service is going down for so and so minutes, so please be aware. They also have to make sure that vendors support them during the testing phase and also possibly during the upgrade night. Okay. So these are some of the items that operations team has to take care of. For us, in this session, we are going to dig deeper into the MOP. Okay. So let's look at what are the steps involved in executing a software upgrade on the night of the upgrade. Okay. Now, the actual procedure will vary from vendor to vendor, organization to organization. What I have tried to put together here is a generic procedure, that will be there in most organizations. So it starts with the planning phase. So whatever we discussed in the previous slide would come under the planning bucket. Once the planning phase is done, then on the night of the upgrade, the first step would be doing a pre-upgrade health check, right? Making sure your hardware is good, your routing protocols are good, right? So that pre-upgrade health check could be using a script or a set of CLI commands. Okay. Once the pre-upgrade health check is good, the next step is to take a configuration backup. So you stop all the provisioning activities, you take the configuration backup, store it in an external location. So in case your router goes down, you can restore that backup and bring the router up. Okay. Once the backup is done, then we can transfer the new software image to the router. Now this transfer process doesn't have to necessarily happen on the night of the upgrade. You can do it earlier as well, store it and keep it in the router, right? So along with the transfer, the router will also need to validate that the software image is valid. So the software image was not corrupted during the transfer. Okay. And then the next step is to activate that software, right? So the activation process again could vary from vendor to vendor, but in general, the activation is done by changing the boot order. So just like a Linux operating system, you change the boot order and say, I want to boot, or my primary boot is my new software version. Okay. Now, once that is done, next step is to reboot the router. So you could activate the software without the reboot earlier on, and then on the night of the upgrade during the maintenance window, you can reboot the router. And once the router is rebooted, comes up with the new software version. Okay. And at the end, just to validate everything, we will do a post-upgrade health check. Again, run a bunch of CLI commands, making sure that everything is good. If we find any issues during the post-upgrade health check, then a decision has to be taken whether we are going to do a rollback or not. And in case we are going to do a rollback, then we have to follow these steps once again. Okay. Now let's look at some of the tools available today to do the software upgrade. So the most common tool that all of us are familiar is using the good old CLI. So this is where the engineer sits in front of the CLI, looks at the MOP, punches in the CLI commands for the upgrade. These commands are vendor specific commands. Okay. The next one is using the vendor EMS system, the management system, right? So the vendor EMS system will support the software upgrade. They will have a procedure, go to this window, click on this, and you can perform the upgrade using that procedure. And in some cases, you will be able to automate that procedure using API calls, but again, you are following the steps given by the vendor. Okay. With network automation, using Python or Go, we can automate that procedure in a script. And then all the engineer has to do is run that script or click on a button that will execute that script. But again, in this case, we are automating the vendor specific steps to do the upgrade. Okay. And lastly, ZTP. Some of you may be surprised, zero touch provisioning is also a tool for software upgrade. How is that possible? So I was personally involved with a customer who was using ZTP for a software upgrade. So what we do with ZTP is we trigger the ZTP process. So before the ZTP process is triggered, we take our configuration backup, store it. ZTP triggers, the software, the ZTP process gets completed, comes up with a blank config, and then either during the ZTP process or after the ZTP process is completed, restore the config, reboot the router again, and boom, the router comes up with the new software with the existing configuration. Now there is one common problem with all of these methods, right, which is they are all vendor specific. Okay. So it sounds ironic, this statement is coming from a vendor. So whether you use any of these tools, they are all following vendor specific commands. So we need a standard way of doing a software upgrade that is vendor neutral, that is accepted by all the vendors and supported by the vendors. So that is the focus of our session today. And that solution is GNOI. So GNOI is gRPC based network operations interface. So it's a gRPC based service. It is originally developed by Google and now supported through OpenConfig. So all the GNOI services and documentation is available in the OpenConfig page. So with that brief introduction, let's look at where GNOI can fit in our MOP. Right? So we discussed this MOP, each of these steps. So let's look at where GNOI can fit in this MOP. So surprisingly, GNOI can be used in all of these steps except the planning phase, which is understood. Okay. So be it post or pre-upgrade health checks, transferring the image, activating the software, GNOI can be used for all these steps. Okay. So with that context, let's dig deeper into GNOI. Now GNOI is a gRPC based service. So before understanding GNOI, we need to understand gRPC. Right. gRPC is a RPC framework, and these days gRPC is interchangeably used with GNMI or telemetry. Right? When you say gRPC, the first thing that comes to your mind is telemetry. Right? But gRPC is a framework that is used for GNMI service, which is actually doing the telemetry work for you. It's not gRPC that is doing the telemetry work. So gRPC is the underlying framework, and GNMI is a service running on top of gRPC doing the telemetry framework. Similar to that, GNOI is another service using the gRPC framework. So gRPC uses HTTP2, and most of the advantages that we see with gRPC compared to other API protocols like REST, it's coming because of HTTP2. So HTTP2 allows for binary encoding, efficient connection management, multiplexing. So these benefits are used in gRPC services. And in order to run any gRPC service, whether it's GNMI or GNOI, we need a client and a server. So in the networking world, the server is most of the times the router. Okay? And we need a client that understands GNOI, and then the client and the server will talk to each other and exchange information. Okay. Now let's look at GNOI. How does it work? Right. So we mentioned we need a client and a server. Okay. So in this case, we have a client running on our laptop or a Linux machine that understands GNOI, and then we have the target node, which is a router that again understands GNOI. Now GNOI has a list of services, and each service has a method, and each method will have certain RPCs. So in this example, we are looking at the system service. So we want to get the actual time on the node, the current time on the node. So we are using the system service. In the system service, there is a time method, and in the time method, there is a time request RPC. So the client will send the time request RPC, and you'll see from the PCAP that the time request RPC is sent inside a HTTP message within the gRPC framework. Okay. When the target node or the router receives it, it processes the request and sends a response back in the time response RPC. Now in the response PCAP, you'll see that the time response RPC has a payload which is in the protobuf format, and that payload has the time on the node. And the time in this case, in this response, is in nanoseconds since epoch. Okay. So the client can take that and encode it in a user-friendly way. So this is how GNOI works. This is the list of all GNOI services that are currently available. If you are familiar with GNOI from the past, you will notice that CERT service is missing from this list. And that is because the search service is now moving to a new gRPC service called GNSI, or gRPC based network security interface. Okay. So for this session today, we are going to focus on the top 4 services: the system, file, health Z, and the OS service. So let's look at each service in detail. So the system service is used to perform system related actions. It could be like a ping or a trace route or a reboot. And for our software upgrade use case, most of these are useful, right? So if you want to do a switch of your control processor, we can use the switch control processor RPC. If you want to reboot the node after activating the software, we can use the reboot RPC. So that's the system service. The next one is the file service. As the name indicates, the file service is used to do file operations on the router. Okay. So this service, in the software upgrade use case, we will use it to get the configuration backup. Or if you want to do a rollback, we can restore the configuration backup from the external server to the router. We can also get, using the stat RPC, we can get a list of files on the router, see how much free space is available in the hard disk or the flash card. Okay. The next one is the health Z service. So the health Z service is relatively new introduction to the GNOI stack. The health Z service is used to check the hardware health of your components. So for example, we want to check our line cards are good and healthy. We want to check our fan cards are good. We will use the health Z service, and the health Z service will respond back with the health of the node. So it will be a value of either 0, 1 or 2 indicating the health of the node. In addition to that, the health Z service will also capture a hardware dump on the router, right? So like a core dump, or in the Nokia world we call it a tech support file. So it captures that hardware dump, and the operations team can retrieve that hardware dump for investigations if there is any issue with that hardware component. Okay. So we'll use this for the for the software upgrade use case as well. Then the OS service. The OS service is the most important one for the software upgrade use case specifically. So the OS service is what we will use to transfer the software image, to activate the software image, and once it's activated, we will use OS service to verify that the router is now running the expected software release. Right? So all 3 RPCs we will use in the software upgrade use case. So let's dive deeper into these 3 RPCs in detail. So the install RPC is what transfers the OS package from your client to your router. And this is a bidirectional streaming RPC. This is another advantage of using gRPC, which provides you bidirectional streaming. Okay. So in our example here, we have a client running GNOI and we have our target router. When the client wants to send a software image to the router, it will send a transfer request. In that message, it will indicate the software version that it wants to transfer. When the target receives that message, it is going to look at the software version and check whether the router already has that software version. Right? So I might have, the router will have multiple software versions already available, and if it is available, then the target will respond back with a validated message saying, I already have that image, you don't have to transfer it to me again. If the target does not have that software image, it will send a transfer ready message, okay, I'm ready to accept your image now. And then the client will start transferring the image. And we can see the progress of the transfer when we execute the GNOI command. And the target has an option to send a transfer progress message back to the client indicating how many bytes have been received so far. Again, that's optional. Depends on the implementation on the router. At the end of the transfer, the client will send a transfer end message indicating that, okay, I have completed the transfer. And when the target receives that, it is going to do a health check of the image, make sure that the image was not corrupted, and then it is going to say it's validated. So it's all good, the transfer is done. Okay. If there is any error during the health check, then it will send an install error message back to the client indicating something went wrong. So in that case, we will have to initiate the transfer again after fixing the issue. So this is how the image transfer works. Now, once the image is transferred over, we can use the activate RPC to activate the image. So within the OS service, the activate RPC. This has options where you can indicate which version you want to activate. So in case you have multiple versions on the target, you can use the specific version in the RPC call to activate a specific version. We can also add the standby option. So in cases where you have redundant control cards, you can do an in-service upgrade where you activate the software on the standby first, do a switch, and then you activate the software on the new standby without impacting your service. The activate RPC also has the no reboot option. So this is where you change your boot parameters, but you don't immediately reboot your router. You might have to reboot it at a later time during a maintenance window. So if the no reboot flag is specified, then the boot parameters will be updated, but the router will not be rebooted. Okay. So in case you are specifying the no reboot option, then we can use the reboot RPC from the system service to reboot the router at a later time, or we can resend the activate RPC again without the no reboot option. So the router will now reboot, and because we changed the boot parameters already, now the router will come up with the new software version. And then we can use the verify RPC to verify the current software running on the router, and the target will respond back with the software version running on the router. Now the software is upgraded, we can do a post-upgrade health check again using the health Z service. Now all these services are good, but we need a client. Right? We need a client that understands GNOI, that talks GNOI. There is a client called GNOI C that's developed by Nokia and available for free to download and use, no licensing. That understands GNOI services, and that can be used to send these RPCs to a target router. So it's freely available to download at this link. And if you're interested in learning more about GNOI and developing your own client, there's an option to go into the OpenConfig GitHub page, read all the different RPCs that are supported by GNOI. Or there is another option where we have a GNXI page, which is a dump of the GitHub data, but in a better human readable format. So this is a screenshot of that GNXI page. You will be able to click through different RPCs and look at the structure of each RPC. So we have the services, we have our client. Now let's go into the demo. So in this demo, a recorded demo again, we are going to upgrade a Nokia 7220 IXR based on Tomahawk 3, IXR H3. We are going to upgrade it from release 23.7 to release 23.10, using the process that we described earlier and using the RPCs. So before we go into the demo, let's do a quick refresh of the software upgrade procedure. Right? So we have to do a pre-upgrade health check, followed by configuration backup, then transfer the image, validate it, activate the image, that includes reboot, and then verify the image, and then do a post-upgrade health check. So here we are using the GNOI tool. So the GNOI tool is installed on a client running Linux. Okay. The GNOI tool needs to know your target node IP, the login, if you're using TLS certificate locations. All that information is stored in that gnoic.yaml file that I'm using here. Okay. And then we are using the health Z service in this example because we are doing a pre-upgrade health check, and we are going to check the health of the fan tray in slot 1. Okay. Now let's execute that and see what it returns. Right. So the output is in JSON format. You can also have it in a human readable format. So this is the fan tray in slot ID 1, and the status returned is 1. So it will return either 0, 1 or 2. 1 means healthy. So in this case, our fan tray is healthy. Now the health-z service also took a code dump or a hardware dump of the router or a tech support file, and it gives us the location of that tech support file. So if we need further investigation to be done on that fan tray which is not healthy, then we can grab this tech support file and open a case with TAC and get it investigated. So the pre-upgrade health check is done. Now we can go ahead and take the configuration backup. Before we take the configuration backup, let's verify the current software version running on the router. So we will use the verify RPC, part of the OS service. And in this example, you can see the output is in human readable format, not JSON. So we can see the current version running on the router is 23.7.2. Okay. So now we will go ahead and take the configuration backup of the router. So here we are going to use the file RPC, the file service. The file service is what we will use for file operations on the router. So here we are doing a get RPC, and we provide the location of the configuration on the router. Okay, so this is where my configuration is stored on the router, and I'm going to get that file and store it on my local client machine. So now the transfer is done, and we can see in the client server that that file is existing in the same path as what we provided. Okay. So now the configuration backup is done. The backup is now securely stored in our client. So the next step is to transfer the software image. Okay. So again, this can be done either during the maintenance window or sometime in advance. So for the software transfer, we are using the OS install RPC. We have to mention the version that we want to transfer and the location of the image that is on the client. Right? So you need to transfer the image to the client and then specify that location in the GNOI call. So when we execute this, we can see the progress of the transfer being done. So it is the image is transferred in chunks of like half MB, and we can see the progress here on the screen. There is no transfer progress message sent by the target in this case. So this is about 1.2 gig file. So we will wait for the image transfer to be completed. And then, as I mentioned earlier, at the end of the transfer, the target is going to validate the image, make sure that the image was not corrupted. And in our case, we are transferring a gzip file. So the target will unzip that file and then store all the relevant binary files in the locations. So in this case, the client send the transfer end message, and then the target send a transfer content is done, and the target has started unzipping the file and putting the files in the right locations. So now our image is transferred over. The next step is to activate the new image. So before we activate, let's check the current version again, right? So in this case, our format is JSON. So we see that the current version is 23.7.2, and we are going to upgrade this to 23.10. So we already transferred the 23.10 image to the router, and using the OS activate service, we are going to activate that particular version, 23.10. So once we issue this command, so we are not using any of the options that we discussed earlier, which is only the standby or no reboot. So in this case, the router will immediately reboot right after the activate message is received. Okay. So we receive the activate OK message, and then the router will reboot, and the boot parameters were already changed. So the router will now come up with the new software version. So assuming the router successfully came up, we can issue the verify command again, and then verify that the router is now running 23.10. Okay. So the previous verify command was in JSON format. Now let's look at the verify command in the human readable text format. So we can see here that the router is now upgraded to 23.10. Okay. So that completes the upgrade. Now we can do a post-upgrade health check using the same health-z service that we saw earlier, checking the hardware health of each component. Now, all these steps we did from our client. We did not log into the router for any of these steps. Okay, and all these steps we did manually, but you are free to have these steps in a script of your preferred language, running GNOI client and getting the format. That's why the format is available either in JSON or human readable. So if you are manually doing it, its human readable format is better. If you are putting it in a script, get the response in JSON format, process it, and then use it in your script. Okay. So that completes the software upgrade. So in summary, we discussed the software upgrade process, the challenge for the software upgrade process. The main issue is that they are vendor specific. Whichever tool we use, we are basically repeating what the vendor process is. We need a vendor neutral way of implementing a software upgrade. This is where GNOI comes in. GNOI is a gRPC based service defined in OpenConfig that can be used for software upgrade. And then we have a client that's freely available, GNOI, that can be used for GNOI based software upgrades. And that's the end. Thank you all for your time. Feel free to ask any questions.
Saju, thank you so much. That's a really great presentation and easy to understand the all complicated steps. My question is, GNOI is quite strong, framework for the software upgrade. What is the real benefits from the scalability perspective?
So from a scalability perspective, it depends on the number of gRPC channels that you can, you just need one channel to one router, right? So from a scalability perspective, there is no issue from a router side. From the client side, it depends how many GNOI channels you can open in parallel to upgrade multiple routers at the same time.
Thank you.
It all depends on the processing power that you have on the client side. Yeah, I don't know the answer for that one, unfortunately.
How do you know how many, what's the performance of your environment and hold it up or simultaneously?
So in general, I guess you guys have to use a mic. It's being recorded.
So usually for the gRPC implementation services, vendors define the scalability parameters, like how many channels you can have at the same time on the router, and it depends on the the processing capabilities of the router. But usually that scalability information is available.
No, he's asking about the client side.
Oh, from the client side, sorry. I think that might be the implementation in the OpenConfig GNOI services. And normally you can have the one session that using the gRPC for the GNOI services, right? So your client, based on the specifications of OpenConfig for the GNOI services, client side can handle that. But there is no specification I have seen so far at the OpenConfig standards for GNOI.
It also depends on the client implementation. So I can check with the developer of the client and see what is supported there. Yes.
Oh, thank you for the presentation. Considering automating this kind of activity, two questions. Is there like a feature requires kind of where the client asks if the device supports or which methods are supported? For example, you presented multiple.
Normally it comes
OS.
with your vendor documentation, which RPCs are supported or which services are supported. But in order to check whether the router is running GNOI or not, you can use a simple ping RPC, or the example that we discussed was the system RPC to get the timestamp on the router. So that checks GNOI is up and running on the router and it is responding to request.
Yeah, I'm going back to a more complicated case where vendors said that I support something, but they support partially. right? So is there a way for me to query all the methods that are supported? Let's say that the timestamps are supported. Is that imply that all the other methods, OS, file transfer, all of them were supported? If not, how do I query the device in case I want to automate if I can proceed with the software upgrade or not?
So system RPC, if that works, it doesn't imply that all the other RPCs are supported. That's not the case.
Okay.
So this is normally done in a lab scenario, right? You will be testing this in a lab scenario. So in a lab scenario, you can send all these RPCs. It doesn't take the router down. I mean, it doesn't impact your traffic. So in a lab case, you send these, OS transfer, install service, verify service, activate service. You can test all that, make sure that your vendor supports that. Right? And then you go into production with these steps.
Okay.
Right? That's the only way to verify it. There is no single command which shows you all the list of services that are supported on the router.
Yeah, I mean, I could talk about it, I guess. So, yeah, I'm not aware of something for GNI that does that. For GNMI, which is there is a capabilities request that you can send.
Yes.
Does send back the list of supported RPCs, which I think is what you're getting at. Yeah, I'm not sure about GNOI, but maybe under the GNMI one, it also lists the GNI ones. I haven't tried that, so it's possible.
Yeah.
Thank you.
A good question. Yeah. Thank you.
Hi, Jeff Gelbach with NetBox Labs. This may be a slightly lazy and out of your lane question, but I assume that GNOIC is implemented in Go. Are there GNOI language bindings for other languages that you're aware of?
For GNOI?
Yes.
So GNOIC, if I remember correctly, is implemented in Python.
Oh, it's Python.
Yeah, it's the same developer who did the GNMI-C. Yeah. Or maybe it's C++. Yeah, I have to.
It looks like it is Python. Somebody here has it pulled up on PyPy.
Okay.
Great.
It's the same developer who did GNMI-C who developed GNOIC.
Okay.
Yeah.
Great. Thank you very much.
Hello, thank you. Michael Tardif here with Sonic.net. I was just curious, starting out with, Google starting this new standard and participating in OpenConfig, was there a specific challenge that was trying to be solved, or was this a technical problem, not an operations problem? Was this let's build a system that we can then try to get vendor buy-in, or was there we have this system that we need to, scale out for internal services or the like?
Mm-hmm.
Do you have any idea behind the history behind that?
I can put some comments on that. So basically, Google doing this was for their own use cases. So they didn't have any plans to have this, globally implemented, but they wanted for their own network. So even GNSI, which we discussed for the search service, GNSI is being developed now for the certificates. That's again being developed by Google, right, with help of their vendors. Similarly, the whole gRPC framework came up to have some advantages over REST or the other API calls, right, which is binary encoding, protobufs, all the resource benefits that they get from the gRPC framework.
So it was more of a, hey, we built this thing, who wants to use it?
Yeah, exactly.
Thank you.
Okay, any other questions? Good. Okay, thank you all for your time.